Hello, everyone, and welcome. We're going to continue on with our discussion of the strings today. So the last time we saw about the indexing and the slicing of the strings. In order to pull out various pieces, the indexing will pull out a particular element of the string, and the slicing will allow you to select multiple pieces of the string. And so now we're going to continue on with some other things that you can do to process the strings. Share my screen here, and as usual, please feel free to follow along either with me on the video or with your the slides from the Moodle. And let me see. Okay, so the next thing we're going to talk about is the string comparisons. So this is another example of overloading, and the operators less than, equal to, greater than, or greater than, equal to are ones that we've seen in math before, familiar ones. So what does that mean for use with strings? We've seen the equals and non-equals in strings already. They're overloaded to say whether or not two things are identical or to confirm that they're not identical. But the less than and greater than ones are going to have to do with the idea of alphabetization. So it works almost the same way as regular alphabetization, but with a few little twists to it. So within the same case, they're compared in the normal alphabetical order, and they will go by position. So it'll basically left justify the two things you're comparing to, and it will start at the 0th position and then pull out each item as you move along and say, does this one come before that one in the alphabet? And it will continue to do this until it finds something that is that you can make a distinction, right? So most times you could just do it for the 0th character, and you could say, okay, A comes before B, that's great. So now we know this one alphabetizes first. But if you can't make that designation, it will proceed to the next character and so on until it can. So within the same case, that's how it works. But if it's not the same case, then there's going to be this convention that the uppercase letters come before the lowercase letters. So that means that basically anything in capitals will come before anything in lowercase, which does not hold true in normal alphabetization, right? That would be like having two dictionaries, right? One with the uppercase and one with the lowercase. But it's not like that in Python. Python does make that distinction. So let's just take a look at how this might work. So I like reading less than, meaning comes before, like in the alphabetization sense. So that helps us kind of just bring to mind what exactly we're trying to say here. So if we say A is less than B, what we really mean is A comes before B in the alphabet, which is a true statement. A does come before B in the alphabet. Being greater than really means comes after. So this says Z comes after Y, which also is true. Notice that we're comparing these using string comparisons because, of course, we're on string, so they have the quotes. The uppercase letters will always come before the lowercase letters. So we get this curious thing, Z comes before A, and that Python tells us true. And we say, well, what's going on here? No, Z doesn't come before A. But when we confer with our uppercase versus lowercase alphabet, we remind ourselves that yes, Z does come to the left or comes before A, the lowercase a. So this is in fact a true statement in the sense that Python is looking at this. So precedence will move from the left to the right as in normal alphabetization. So if you try to compare, okay, Z comes before A, we've just seen is true. Now let's say we have capital Z, lowercase a, and lowercase a, capital Z. So we'll begin by looking at the 0th character. So capital Z comes before lowercase a, just as we've seen here. So Python looks at that and says, yes, I can already make a determination. It's true. Now this says capital Z comes before a capital A. So that's not true because now we're within the same case. So that's false. And here we have lowercase z comes before capital A. no, that's false. Capitals always come before lowercase, so we could already make a designation there. And now we have ZA, so we have lowercase z and lowercase a comes before lowercase a. No, that's false, so we get a false. So all of these were actually able to be determined on the first character. So we're going to proceed from left to right from the first position at which a determination can be made. So for example, if we have boat and boot, here we see that we can we compare B to B and no determination can be made. And then we go O to O, no determination. A to O, A comes before O. Yes, that is true. So this will be a true statement. So now what if we're going to do boat and boot like this? So because they differ in their capitalization, this says lowercase b comes before capital A. So although boat and boot should be, like in a normal dictionary, boat would come before boot, but because of the capitalization here, Python tells us false because lowercase b does not come before a capital B. And now we have these Z's with an A and some Z's over here. So we're going to say lowercase z comes before Z, no determination. Z comes before Z, no determination. Lowercase a comes before lowercase z. Okay, there we have a determination available, and that is true. So that's how Python would do those string comparisons. We also have the positive integers to be compared as strings. So it's possible to compare numbers as strings, but this is really not something you want to do. So let's see what's going to happen when Python tries to do this. So you say the string 0 comes before the string 1. So here they are, and that's true. And as string precedence follows the alphabetic convention and not numeric convention, it will left justify them, and it will start. So that means it's going to start with the leftmost character, and it says it will process it like that. So of course, 100 is not less than 20, and when we compare them as integers, we get the normal designation that that's false. But look at what happens when we try to compare them as strings. So we say 120 as strings. Python says, is 1 less than 2? Oh, yes, 1 comes before 2. Look at that, it's more to the left. So the answer is true. And of course, we get this bizarre answer that 100 is less than 20 comes out as true because it's processing it as a string. And so the moral of this is that you really shouldn't be processing numeric things as strings for string comparison unless there's a real reason for you to be doing that. But I'd be hard pressed to think of a reason why you would want to know that. There's also rules for characters such as punctuation, the negative sign, decimal, and many others, and they're all ordered. They're actually ordered by the ASCII table. So I don't really see that there's a point in memorizing that. So just know that all of the things are order. You should know how to do the ordering for the capitals and the lowercase, and know that this problem happens with the numbers. But if you have some other character, you can just do it in Python and find out, and you should understand that that means that it's like lower in the table than another one, and so on. But numbers also really should be just compared as their proper type and not as strings. So true or false, determine if Python will return true or false. So if we do Huron.upper is greater than Erie.upper, Superior.lower is less than Michigan, Ontario, camel case. We call this camel case because you see capitals and lowercase are missing, and it's kind of goes up and down. That's called camel case, is less than Ontario, and Ontario.lower is not equal to Ontario.lower. So why don't you pause the video and take a few moments to see what you think the answers are, and we will be happy to reconvene in a moment. All right, so I hope that you were able to process a number of these. You don't have to take my word for it. You can also type it into Python, but let's just take a look. Huron.upper is greater than Erie.upper. So this, of course, is going to convert all of these into uppercase. So we'll have capital H compared to capital E. Does H come after E? E, F, G, H. Yes, it does. So that's a true statement. Here we have superior dot lower, and is that less than Michigan? So we'll have lowercase s compared. So lowercase comes before capital M. We know capitals always come first. We can already say that one is false. All right, here we have all these crazy cases. So let's see, we'll start with the capital O and capital O. That's the same, no determination. N comes before lowercase n, no determination. So here's the first one where there's a difference. Uppercase T comes before lowercase t. That's true. So we get a true designation. All right, now we're going to convert this to lower and Ontario dot lower. So we said these are not equal to each other, but if we convert both of them to lowercase, they will be equal. So this is false. All right, great. Now let us talk about the in operator. So the in operator takes two strings as operands and returns a Boolean. It returns true if and only if the left operand occurs as the substring of the right operand. Otherwise, it will return false. So if we have left operand in the right operand, so if we want to say, for example, is super in superior. So again, this is going to return a Boolean that's sort of like asking a question. It's sort of like an is in kind of a thing, if you will. Is super in superior? So we have two string operands, super and superior, and so superior does contain super, so we'll get back a true. And then if we ask is great in superior, that is false. So those are pretty easy ones. There could be a few other examples, and again, we're always thinking about those edge cases and what if, because you never know what could cause your code to go crazy. So it's good to be aware of these things. So if we take a look at a slice, does the slice need to be consecutive? So is sir in superior? So I could say, oh, sure, look, S-I-R, just like that. But that's going to return false because it has to be consecutive. The search is going to be case sensitive, so we could say is Ron and Huron, and well, it's right there, R-O-N, but the case is wrong, so it will be false. It will only do a forward search. Can you find a rat in Ontario? Oh, there it is, R-A-T, but that's backwards. So you're going to also get a false for this one. Here's a little exercise for you to do with the in operator. Write a function called word search that takes two strings, S1 and S2 as input. It will check if S1 is a substring of S2 and return true if it is and false otherwise. The search should be case independent. Test with on in Ontario. All right, and so this is showing you what this should look like. Now, this is a great review. Back to the function. So you should be writing a function called word search. Here is our function call. So the calling of the function is interactive, but you should be putting your word search function in your script, and then you'll do run module, and you can call it from your module. Actually, you should, but you can do some testing by also running it from your interactive interpreter. And so this should be returning true. Notice that on in Ontario, right? I mean, it's not an exact match. So keep that in mind as you think about how you might work this. So let me go ahead and give you a few moments to do that. Why don't you pause the video and we'll see you back here in a few moments. All right, welcome back. So here is a solution to the in operator exercise. We were trying to write a word search that's going to take two strings and return true or false. It's case insensitive. So if it were case sensitive, we could just use in. But the problem is, of course, that in is case sensitive, and so that's not going to work. But we know how to use those string processing to convert to the same case. So I've chosen here to take in two strings, right? So here's my function. I'm going to take in two strings. This is how you should be doing it. You should be passing in two strings, and we should be converting string one to upper. So here we are doing a variable reassignment. So we reassign S1 to its equivalent in uppercase, and we do the same to S2 also in its uppercase. And then we can Okay, we could do this in a two-step process. I've done it in a one-step. So we need to know whether S1, now being all caps, is in S2. Notice you also could have done this in lower. So you could have done S1 dot lower and S2 dot lower. You could really do either way because it will convert them all to the same case. That's the critical thing here. And so then we are going to see whether S1 is in S2 now after they have been converted. So you could store that in a variable and return the variable, or you could do as I've done here. It's a sort of like a composition. I've returned the expression S1 in S2, which will return a Boolean. Let's just double check our signature here. So we have two strings. So this is the correct designation. And here we have a bool is the output type. So we see that that is going to be a Boolean because in returns a bool. And now we can call our function asking for on, whether on is in Ontario, and we will get back true. All right, thanks so much. We are going to pause right here. Stop right here. Thanks so much for joining us. We hope this was helpful in understanding a little bit more about the strings, and we look forward to joining with you next time. We will then pick up on these strings with the looping. All right, we'll see you then. Bye-bye.